Welcome back to orthogonal trajectory. All that we are going to do under orthogonal trajectory is so simple. It's about tangent and what? Normal. Now, we know that a normal is the same as what? A perpendicular line. A perpendicular line is the same as what? Orthogonal, right? Orthogonal. So when we talk about orthogonal, it's the same as what? A normal. We know that when we find dy ds is the same as what? A gradient. Alright, and that's the same as a tangent. But to get the normal is, if the normal is m2, that is negative 1 over what? The n. That is negative 1 over what? The n. So anytime you find dy ds, to get the orthogonal trajectory is to take the negative reciprocal of the what? Of the dy ds. I hope you are getting what I am saying. After getting dy ds, let's say dy ds is equal to a. So the orthogonal trajectory is also dy ds. But with that one, this is representing something like the m2. So with this, we take the negative reciprocal of the what? Of the first derivative. Okay, good. So that's what we're going to do. It's not anything difficult. Just take the negative reciprocal of results of your results. So solution A. Find the orthogonal trajectory for the following family of what? Curves. So we have y squared is equal to s plus c. So first of all, our target is to find dy ds. So to find dy ds, we know that this is an implicit word differentiation. So we are implicit differentiation. So we are differentiating this in terms of what? As respect to x. So this is 2y dy ds equal to differentiate this, get 1. Alright, and whenever you differentiate a constant c, you get what? 0. Very good. So to get dy ds, you make dy ds the subject, and dy ds is going to be equal to 1 over what? 2y. So to get, it's like, to get the m2, you take negative reciprocal of what? The first what? And the m1 representing this, and the m2 representing when you are taking the negative what? Reciprocal. Normally, people forget to take the negative reciprocal after getting the first one, after getting to this side. So here, dy ds here is now going to be equal to the negative reciprocal of this is going to be negative 2y. I hope you can see that. That is going to be the negative reciprocal of this. So this represents m1 and this represents m2. I hope it's clear. But you don't need to be repeating this m1 and the m2. We know that after making dy ds the subject, then you take the negative reciprocal of that. And now you resolve this with the idea of separable differential equation. Now, we have other methods in solving differential equation that you can resolve into it. But for now, what you know is separable differential equation. So it's not always that you are dealing with orthogonal trajectory. We apply separable differential equation. It depends on the differential equation that you have. Don't forget that. I know the reason why I'm saying that. When we get there, I will let you know it. Alright. So we can solve this only by separable differential equation. So 1 over 2y dy is equal to what? Dx. So integrate both sides, and we are going to get negative half 1 over y dy is equal to integral of this. So we get ln y is equal to s plus c, and We all know already, okay, that here we are going to get lane y negative half s plus lane c. So this is lane 1 over square root of y algebra is equal to minus lane c is equal to s. So we get lane, since here is subtraction, we divide, so we get 1 over c square root of y is equal to x. So that becomes the final answer for that. That is why you have to find the orthogonal trajectory for the following family of what kept. So you are going to leave your answer in general what solution. In general solution. So that is going to be your final answer for that. But sometimes you can even continue to manipulate your questions, but you don't need to go and do that. Somebody can say that, okay, since I'm having y here, let me take square root of both sides so that I can get y and come and substitute back to this. Please don't worry yourself, leave it aside. Alright, so it's not difficult. All that we are doing is that take the first derivative. After taking the first derivative, make dy dx the subject, and that represents the m1. To get the m2, repeat the same dy dx, but take the negative reciprocal of your results. So the negative reciprocal will give you what is there. Then you continue to solve it by a separable differential equation. So the first target is to take the derivative. Product rule. And we are taking the derivative with respect to what? X. So leave this, differentiate this, you get dy dx plus differentiate this, you get 1, and leave this is equal to c. So you make dy dx the subject. So s dy ds is going to equal to negative c minus y. Okay? Alright. So now, to make dy ds stand alone, you divide 2 by x. So this is what we have. So what we are saying is that to get to m2, this is just m1. So to get to m2, you write dy ds, then you take the negative reciprocal of this, so you get negative s over c minus y, the negative reciprocal. Then you resolve it with the idea of separable differential equation. So to resolve this with the idea of separable differential equation, we now move on. So here, dy will be here, ds will be here. This will be just 1 over c over y, and this will be negative s. Alright. That is that. Integrate both sides. And when you do that, here you're going to get c is something like 2, 3, 4, so don't worry. So c minus y is equal to this, we get s squared over 2 plus c. That is your final answer for that here. You can leave it as such, or you can continue to what? Manipulate it by saying that c minus y, then this one will come to this side. So c is equal to negative s squared over 2. Then here we get c c minus 1. It will even divide. Okay, it will even divide. C is equal to s squared over 2. So that will be the final answer for that. So all that we are saying is that take the derivative, take the negative reciprocal, and resolve by separable differential equation. Alright. Y is equal to cos s plus c. So first of all, take the derivative. dy dx is equal to what? Differentiate cos s, you get negative sine s plus. And when you take the derivative of this constant, you are going to get what? 0. You are going to get what? Plus 0. It seems in the previous example, this one, I forgot to equate this to 0. Please do that for me. Here, there is a mistake. And that's why we are still having this C inside. Because this shouldn't have been there. Make sure you correct that for me, okay? Alright, make sure you go and correct that for me. Okay. Because after the product rule, we should be equating to what? 0 and not C. Please do that for me. I beg you. Alright, I trust you will do it. So everything here will be 0, 0, 0, 0. So the final answer will just be the negative y plus c to be equal to this. Okay, thank you, and I trust you will do that for me. Alright, so as you can see, it's because of the time. Okay, so from here the derivative will give this, and when you are done, this is just the m1. When you get to this side, you have to take your time, because people normally after here then they begin to solve by separable differential equation without taking negative reciprocal of it. And when you do that, you contradict yourself with the concept of what? With the concept of orthogonal trajectory. So here we are going to get dy to be equal to negative sine s ds. Integrate both sides, okay? Y is equal to, here you get cos. When you integrate, when you integrate cos, when you integrate sine, you get negative cos. So here will be positive cos s plus c. Alright, so that is going to be your final answer for that, because you have taken you have forgot to take the negative reciprocal. You see, when you do this, this is what I was just saying. This is wrong. Why is it wrong? Because we didn't take the negative reciprocal of this before solving it by separable. So it makes it wrong. Never and ever in your life make such what? A mistake. Never and ever make such a mistake. Oh, after that, I'm done with all. But when after marking, then you will now see that, oh, small mistake. In mathematics, there is nothing like small mistake. In fact, if you are wrong, you are wrong. Alright, so from here, then we take the negative reciprocal, and negative reciprocal of this is going to be like this. Okay, so now we solve this by separable. So dy is going to be equal to 1 over sine s ds. So you integrate both sides, and this is going to give you y is equal to, when you integrate this, what we do, don't forget that 1 over sine is the same as what? Cosec x dx. So y is equal to sec, let me write it as cosec s is just going to be ln cosec s minus cot s plus c. So this is going to be our final result for that question. Alright, where are we? We are done with this. We are now here. And I hope we can continue with this one. In fact, I would like you to continue with the rest. This is just s squared minus y squared is equal to c. So here you get 2x implicit. 2y dy dx. Please don't forget this is not c, it's 0. So when you differentiate a constant, it's 0. Alright. So you make dy dx the subject. So you get 2y dy dx is equal to, it's like sending this one on, so together with 1, 2x. So dy dx will be equal to 2s over 2y. So dy dx is equal to s over y. When you are done, please don't begin to solve it by separable differential equation. Be a separable differential equation, but please don't separate it here. Before you do that, take the negative reciprocal of this and you get y over what? S. Before you solve by what? Separable differential equation. So you get s, no, 1 over y dy is equal to negative 1 over s dx. And when you integrate those, you get ln y is equal to negative ln s plus ln c. You know why I'm making it ln c? So ln y is equal to this to this side. So you get ln c minus this. Hope you can see what I want to project. So you will get c over x. Alright, so take e of both sides, so you get y is equal to c over x. And then we can get the final answer for that. Alright. Oh, continue with the rest. Solve this, solve that. Alright, so that will be the end of. So I leave the 2 questions for you to go and try. Alright. Now, there is a question here under orthogonal trajectory that I would like to read it for you and tell me what is going to be. Here it says that find the orthogonal trajectories of the family of circle with center at the origin and r and radius r. Find the orthogonal trajectory of family of circles with center at the origin. So with this, just know that to be able to decode or come out with what the person is specifying from you is very, very, very important. So find the orthogonal trajectory of the family of circles, and they say that it's of center. Alright, it's of center. That means that it is just the center is just at the origin. So that means that it's going to be s squared plus what? Y squared is equal to what? R squared. So this is what the person wants to tell you. So you just find the orthogonal trajectory of this. So you just continue and see you in our next tutorial. That is going to entail with homogeneous differential equations. See you.